Welcome to the U-Sub with Algebraic Techniques video. We're going to begin by doing 3 review questions. You can try these on your own, but I will go through the solutions with you in detail because I know that we covered a lot of information in that last few videos. So go ahead and try questions 1, 2, and 3, and then when you're ready, we'll go through the solution together. Okay, for 1a, if we take the derivative of the whole denominator, we're going to get back 4x, which is almost like what we see in our numerator. It's just off by that coefficient of 4, but we can always move around those constant numbers. So we're going to let u be 2x squared plus 1. Du then is 4x dx. Now I'm going to do some replacing. So my denominator is going to turn into u, because that's what I let it be. Then this x dx is going to change to a quarter du. And then I'll move that quarter to the front and change the u into an exponent. So here we're going to, if we added 1 to this, we're going to get 0. So we're not going to use the power rule here, the reverse of the power rule. This is actually the derivative of ln. So we're going to get a quarter ln, absolute value of u, plus a constant. Then we can put back the u, which is 2x squared plus 1. And that is our final answer. Moving on to b, if we take the derivative of tan inverse x, we're going to get back 1 over 1 plus x squared. So I'm going to use tan inverse x for my u, then du is going to be 1 over 1 plus x squared dx. So this will be u, and this whole 1 over 1 plus x squared dx turns into du. Now we're going to reverse the power rule. So I'm going to add 1 to the exponent of 1 and divide this 2. Now I'm going to replace the u with tan inverse. And that is our final answer. Moving on to c, if we take the derivative of ln x, we're going to get back 1 over x. So then du is 1 over x, and don't forget your dx. We do have a definite integral here going from 1 through 5, so it's up to you which method you're going to use. I think I'm just going to find my new bounds right away. I'm going to do that on the side. So we need to calculate u of 1 and also u of 5. So I plug 1 into my u, which is ln 1. And then for 5, I'm going to get ln 5. Take a note that this ln 1, you can simplify this more, because that would be e to the power of what gives you 1, and that's going to be 0. So our bounds are 0 to ln 5. Now I'll replace my ln x with u, and that 1 over dx, 1 over x dx changes to du. Now I'll take the antiderivative of u to the power of a half, which is 1 plus negative a half, and that is going to be a half. Then I divide by a half, and if I do that, I'm going to flip the fraction, so I'm multiplying by 2. Now I'm going to change this into an exponent and then apply my antiderivative. So I'm going to add 1 to a half, which is 3 over 2. Then I have to divide by 3 over 2, which changes to 2 over 3. We're going to integrate this from 0 to 5, ln 5. Okay, so it's 2 over 3 ln 5. To power 3 over 2 minus 0. And I'm just not going to write that down. So I'm just going to leave that as our final answer. For our next one, if we took the derivative of x squared, we're going to get back 2x, and it's okay that we don't have a 2 here because we can manipulate that. We don't want to change our sign because the derivative sign is cosine that is not present. So our u is going to be x squared. Du is 2x dx, but I'll move the 2 to the other side because we only have x dx inside our integrand. I could also find our bounds first. So we're going to find u of negative pi as well as u of pi. So then we have pi squared and pi squared. Well, that means our bounds are the same. But I'm still going to do my replacing first before I say this is equal to 0. Okay, so our bounds are the same. And then I replaced the x squared with u and the x dx with a half du. But because our bounds are the same, then we're just going to get 0 for our integral. Question 2. I want to find the linearization of this integral at x equals 2. Well, we also need the y value of this, so we do want to plug this in into the integral to solve for that y value. So that'll be 1 to the power Okay, so for question 2, we want to find the linearization of our integral at the point where x is equal to 2. I do need to find that y value of this because we have the x value, so I'm going to have to plug this 2 into our x here and then solve for this integral. So 2 times 2 in our upper bound is 4. Now I'm going to take the antiderivative right away because this is just the reverse upper power rule. So you can add 1 to the exponent, that's t to the power of 3 divided by 3, plus t squared minus 4t, evaluated from 1 to 4. So that's 64 over 3 once I insert the 4 into t. So it's 4 cubed is 64 plus 16 minus 16, subtracted by, now inserting 1 into t, 1 over 3, plus 1 minus 4. Simplify this, and eventually you should get 24 after all that simplification. Now, in order to find the linearization equation, we do need to find the slope. So now we're going to take the derivative of our integral to get the slope. And when we do that, we're going to use a fundamental theorem of calculus part 2 because our bounds has a function in it on our upper bound. So according to that rule, we're going to insert this 2x every time we see a t, and that's how we're going to take the derivative. So this is 2x squared plus 2 times 2x minus 4. And remember to multiply it by 2 because that's the derivative of 2x according to the chain rule. Now we're going to insert x equals 2 into our x. So this will become 4 squared plus 2 times 2 times 2, which is 8. So that's 16 plus 4, and multiply this by 2, so this will be 40. And that is our slope. So we have our points. Our point was 2, and we found the y value, 24. Now we're going to put it all together. And then our slope was 40, x minus 2. And we can leave it like that. Question 3 is an old exam question, so please maybe start or take a note because it could show up on an exam again or something very similar. I don't have that much room here, so I'm going to answer some of these questions down here. Answer A down here. We want to find g of 4, g prime of 4, and g double prime of 4. So g of 4, I'm just going to use our equation that was given to us. So we're integrating from 0 to 4 of f of t dt, which means I'm looking at the area from 0 to 4. So all of this. So this area here is going to be 2 times 1 divided by 2. And it's also negative because it's underneath the x-axis. This next section here, I'm actually going to break this into pieces. That we have a rectangle and 2 triangles. So this rectangle is going to be 1 times 2, which is just 2. Then here we have 2 times 1 divided by 2. And we have another one on the other side. Then we want to simplify this. So this is negative 1 plus 2 plus 1 plus 1, which is 3. Okay, for B, for g prime of 4, we're going to look at the y value of f at x equals 4. And that is located over here. So this will be 0, because that is our y value there. In other words, we can look at the y value of f at x equals 4. To find g double prime of 4, we're going to look at slope at that point. So if we take a look at our slope here, looks like we go over 1, down 2, which means we have a slope of negative 2. So this is the slope of f around x equals 4. For part B, we want to find out if g has a relative minimum, a relative maximum, or neither x equals 1. So if you look at x equals 1, our f values change from negative to positive. In other words, it looks something like this. That creates a minimum. So again, if you look at the slope around 1, these are negative values, and then they go to positive values. So that means we have decreasing then increasing and creates a minimum. Lastly, for C. This was quite tricky. It says that we have a period of a length of 5, which means if I want to continue on with this graph, it's going to look like this, and it continues on and on and on with a period length of 5. So we're given that g of 5 is equal to 2. We want to find g of 10, and we want to write an equation for the line tangent to x equals 108. Okay, so the first thing we can do is find g of 10. So for g of 10, we know it's going to repeat itself and look something like this. It would help if we found the area from 0 to 5, and then we can replicate that because we know the shape is the same. So let's find the area from 0 to 5, because it would look like this is what we're actually going to do. And we know that these will have the same value. So from 0 to 5, this area here is negative 1. Here it's 4. And then down here, this is negative 1. So overall, that's 4 minus 1 minus 1 is equal to 2. So that's from 0 to 5. And then we know from 5 to 10 is also going to be 2 because it repeats itself. So g of 10 is 4. Moving on to the second part of this question, write an equation for the tangent line to the graph of g at x equals 108. Okay, so there's a few things we need. We need the y value of this, and we also need to find this slope to create this equation. Okay, so maybe let's just find the slope first. So we're trying to find g prime of 108. We also know that this is f of 108. Now, I'm not going to continue this graph on forever and ever just to find the value, but I do know that it repeats itself. So let's just say that this is 100 instead of 0. Then I know my 8 is going to be over here. But this is also repetition, so really it'll have the same value as this one here, which is 2. And that would be our answer. Again, I will explain it one more time. Let's just say that on our longer x-axis, this is 100. Then I know that my value will be somewhere along here to get 108. But I don't have an exact picture right here, so I can just back it up because I know that this shape is the same as this one over here. And it would be the same position as this 3 because 108 would be the same position as 3. And that value we have is 2. Okay, so that is why g prime of 108 is 2. The next thing I want to do is find the y value when x is equal to 108. Now, we do need to figure out how many times we're going to repeat this process all up to 108. So we can do 108 divided by 5 for the period of 5. This occurs 21 times with a little extra 3. So I'm just say remainder 3. Now when we find g of 108 then, because we are finding areas when we're doing this, we know it already occurs 21 times. For our period is going to recur 21 times, and the period length is 5. And we know the area of this is 2. So the area is 2, and this is going to occur 21 times with a period length of 5. Plus that little extra bit we still have to calculate. So this is for area to 105, and then we need to calculate the rest of this. So 21 times 2 is 42. And then we'll take a look at the area from 0 to 3. So from 0 to 3, we have -1, 2, and 1. So then this is just going to be 2. So that value is 44. So I'm just running out of room here. So we're going to put this all together. This is your y value. Your x value is 108. Your slope is 2. So y minus 44 times 2x minus 108 is your final answer. Pretty long and lengthy question.